Hello. This presentation will discuss Athena Food Services Incorporated, consisting of group members Aidan Komendantov, Elena All, Nicholas Nutt, and myself, William Witten, and our plans for large-scale production of the food additive monosodium glutamate. What is monosodium glutamate, or MSG for short? MSG is essentially the salt form of the naturally occurring amino acid, glutamic acid, with a sodium ion substituted in place of the proton on the amino side carboxylic acid group. Its main purpose is as a food additive, mainly a seasoning used to bring out and enhance savory flavors in meats and other savory foods. Early commercial manufacturing of monosodium glutamate saw production through the use of the bacterium E. coli. Our production method involves the use of a different species known as C. glutamicum, which is safer as it is not known to be a pathogen like E. coli, and it is more efficient in terms of production of glutamic acid as well as other amino acids. Our company's goal is to produce MSG on a large scale in a manner that allows for affordable pricing and thus easy consumer access. We hope to maintain a high level of quality and purity in our product while still marketing our product at a low price. We aim to achieve this through efficiency in production, such as the aforementioned staggered fermentation to avoid downtime, as well as recycling our water used in various stages of production and recycling our MSG containing solution to minimize loss of product. This is our quality function deployment, comparing customer needs to the specifications required to meet them. Here you can see that our top priorities are the quality of raw materials used in production and a thorough purification and refining process for our final product. This aims to meet our top consumer needs for a food seasoning product, which are simple: to make sure it tastes good and does not contain any abnormal flavors from impurities, and to ensure the overall purity and safety of the product.
Moving on to the production process of MSG, MSG can be obtained in several different ways. They can be attained through extraction, chemical synthesis, bacterial fermentation, and enzymatic catalysis. Our company will be focusing on bacterial fermentation as our method of production. It has 3 stages: the fermentation stage, the purification stage, and the water supply stage. The fermentation process consists of 2 feed fermenters and a main production fermenter. All 3 use the same medium. It consists of glucose, a nitrogen source, nutrients, and oxygen. A blending tank is used to agitate the mixture, and the mixture is then sent to a sterilizer. Once sterilized, a bulk floor 3-way splitter divides the media into 3 different streams. Once the sterilized media is divided into 3 streams, the broth is then sent to the next feed fermenter. All fermentation procedures include the following operations: the steam in place, which ensures sterile conditions, the pull-in media, pull-in water, the transfer in NH4OH, where pH is adjusted with the addition of ammonium hydroxide, which is also the main source of nitrogen, pull-in inoculum, the fermentation stage, where the microorganisms grow and convert glucose and other nutrients into glutamic acid, the transfer out stage, and the clean in place stage, which takes place at the end of each batch and includes an initial water flush, a wash with 2% NaOH, and a final water wash. The transformation in all fermentation operations is represented by the following 2 reactions. The 95% conversion rate of the second reaction is based on the glucose that is not consumed by the first reaction. Following the main fermentation, the broth is then transferred to a storage tank. This tank acts as a buffer tank that receives material from the fermenters that operate on batch mode, and also feeds continuously the downstream section, which operates in continuous mode. The broth is then sent to a continuous rotary vacuum filter where almost all the biomass is removed. Following the fermentation stage is the purification stage, where the product is currently in solution. The cake is washed with water, and the filtrate of the rotary vacuum filter is heated and then passed through a mixed bed ion exchanger. The mixed bed ion exchanger has following operations. It has the load, the wash, the regenerate 1, where the column is regenerated with 2 bed volumes of 1 molar HCl solution, and the regenerate 2 stage, where the column is regenerated with 2 bed volumes of 1 molar NaOH solution. 2 ion exchange units are operating at all times. While one column is in load mode, the other column undergoes washing and regeneration. After the ion exchanger, the glutamic acid is neutralized with sodium hydroxide in a continuous neutralizer to produce monosodium glutamate according to the following reaction. Here you can see the reaction and that the conversion rate is at 100%. Following these stages, the condensate and vapor streams are sent to the water supply section for recycling. The concentrated product solution is then sent to a continuous crystallizer and is cooled using chilled water. The solubilized MSG is converted to crystal form, MSGCr. Following crystallization of MSG, the crystals can be recovered and washed using a set of 3 basket centrifuges. These include the following operations: the filter, the cake wash, and the transfer out. The washed MSG crystals are then sent to a rotary dryer, which removes 99% of water using air heated with steam. The final product purity will be 99.5%. Finally, following both the fermentation and purification stages of the MSG production process, is the water supply stage, where water is evaporated from the product stream and condensed. This water is mixed with any remaining vapor condensate, and any unused condensate can be recycled back to the fermentation section. With this, the net water needs of the overall process can be reduced.
This is the fermentation block of our PFD. On the left side, we have 3 sections. The first section is for the sugar broth mix for the bacterium to grow in. The second is for the ammonium hydroxide mixing, which is used to regulate the pH of the fermentation batch. And the third is for air filtration, which is used to feed air into the fermenters as they need the air to create the glutamic acid. Once these mixes are made, 2 are sent to seed reactors where they create an inoculum, which is then fed into the final reactor, B6, which we will be using to generate all of the glutamic acid. Once the glutamic acid is generated, we'll send it down the PF1 stream, and from here we'll send it to a centrifuge, which will separate out the biomass, which is then processed and resold, and the other portion is then sent down PF to be sterilized and then sent to the neutralization block. From the fermentation block, we arrive at the neutralization block. Here we will take the glutamic acid that is full of impurities and purify it, running it through an ion exchanger. It is then taken into a mixed tank where it will be combined with sodium hydroxide to form MSG. We'll then send this water and MSG solution into a crystallization vat where the excess water is boiled off and we can recover as much MSG as possible. This is then sent to a centrifuge to where it is separated out from its liquid component. The liquid component is then sent back to the tank to be recycled, while the solid component is sent to a clarifier to be cleaned, and then once cleaned, it will be sent through a rotary dryer to be dried to a 99.5% purity and sent to storage. Finally, we arrive at the water management block of the PFD. As you can see, any steam is condensed back to liquid form and then ran through 2 separate forms of filtration, solid to liquid and liquid-liquid filtration. Once purified, the water is then sent to storage for when it can be used for the next batch. Onto the material balances portion of the project. On the left-hand side, we have the raw materials used to create MSG, and on the top row, we have each of the streams present on the PFD. The columns that are blue in color are to denote water being ran in or out of a process unit. The deep blue cell on the third table is to point out that water was generated from a chemical reaction involving glutamic acid and sodium hydroxide forming water. Onto the final table of material balances. The golden column shown is the recycling stream sent back to the mixing tank containing uncrashed MSG and water to be recovered for a later batch. Below this, we have the totals of the water in streams and the water out streams. You'll notice there's a slight difference in the numbers, and this is due to the recycling stream as well as the generated water from the MSG reaction.
For energy balances, the company calculated the energy balances for each process unit for a single batch. The process units consist of 3 heat exchangers, 1 condenser, 3 fermenters, which consist of 2 seed and 1 main, 2 rotary dryers, and 1 distillation column. To the right, you can see an example of one of the calculations for our heat exchanger 1, and you can see that the energy required for it was 1.5236 10 times 10 to the 10 power joules. You can see the total energy balances for each individual process unit in the table on the slide here.
Here we have the economic analysis for our MSG production. And as we see here, the equipment cost featured in the ISBL limit is totaling out to approximately $5,132,000 US dollars. Now note that the majority of this comes from the 9 total fermenters we have running, as well as the evaporating system. Here we see the breakdown for the construction costs, total material costs, and total variable costs. These combine with the equipment costs to make up the total ISBL of $50,354,225. See the total costs and profit associated with this process. The total capital cost is estimated to be $85,098,640, with the fixed production cost being only $4,726,213 per year. The cash cost of production is going to be about $46,548,438, with the estimated $33,451,562 gross profit. Now, this all comes from our $80 million in gross revenue due to our $1.60 per kilo MSG sale price. On this slide here, we see the payback period, which is estimated to be just over 2.5 years, so roughly 2 years and 6 months. And with the annualized capital cost formula on the slide here, we see that our payments equal out to about $40,826,186 per year, with our total cost of production totaling to about $87,374,624. Now, after the payback period, the profit will be made at approximately $33 million. Our ethical code is short and simple and follows the fundamental canons of engineering. Security measures. Our factory will have flame retardant building materials such as the walls and ceiling panels, plus fire extinguishers, fire blankets, and chemical showers, as well as eye wash stations for safety. Our advanced waste disposal and filtration system allows us for more recycled water, as well as less harmful chemical runoff into the environment. And one thing we require is that every associate must go through adequate training through a superior before working in the field. In conclusion, our method provides a safe, efficient, and very profitable process for MSG production, with a very ideal payback period of 2.5 years, as well as an extremely generous $33 million of estimated profit to be made after debt is finally paid off. Not only this, but this is an excellent long-term investment. $334 million can be made after 10 years of investing, making this very ideal and secure.